Hi, I'm Tim. Join me in this video as we take the Guillows kit of the Piper Super Cub 95. We'll build a kit, convert it to radio control, and come up with this. Let's get to it. Let's do an unboxing of this Guillows kit. First of all, this is one of the newer kits. You can tell because it has a laser cut symbol here. That means the parts are laser cut and it's a very high quality of balsa. It's a 24-inch wingspan, which is normal with these lines of Guillows light flyers. This will be my 8th Guillows conversion. I'll be using the ParkZone equipment, which we'll go on to later on the build. Target weight needs to come out at less than 3 ounces. So first of all, we have the plastic cowl, which is helpful. These are some plastic parts for the wheels and prop. I may use the wheels. We'll see what's happening, how much they weigh. This is a very handy photo isometric guide for building the fuselage and the wing, just the whole kit. Just taking a look at it, fairly standard process for the Guillows kits. As I've done before, I'm going to cut off this main section to have a continuous wing on the top to keep everything aligned. Just a preview, when I put in the equipment, we do that before. We put in the 3/16" stringers. The wings are a very normal construction. I'll use half the number of wing ribs that are shown here on the plan in the picture just to save weight. Also, from experience, the tail surfaces, vertical and horizontal, will be solid 1/16" balsa. That works fine for these sorts of models. It's a very nice decal set. This is one good thing about the Guillows kits. The plans are well done with the laser provided kits. Again, this is a very simple model. There's just one sheet of plan. Side view of the fuselage, instructions for mounting the gas engine. Don't have to worry about that. A good little 3-view along here. Tissue covering, if you're going to use tissue, I'll be using heat shrink covering for mine. And then just standard Guillows construction for the wings. Again, I'll have a solid wing, the fuselage side, the panels, and the tail surfaces, as well as a fairly big windshield template. I'll make some modifications to the gear just to make it a continuous one. I don't advocate having this balsa. It's just going to fall off on any landing. Also, this will be a 3-channel model, rudder, elevator, and throttle with the ParkZone equipment. And finally, there's just balsa wood in here, the lot of 1/16" stringers, the rubber bands, which you don't need, and just all the parts cut from the balsa itself. Again, very good quality wood, plastic for the windshield, and then the tissue covering. So that's the unboxing of this kit. To control and power this model of the Guillows Cub, I'm going to use the ParkZone Ultra Micro RC equipment. There'll be a description in the link of a video where to get this. I get mine from Steven Zero, and this is a remarkable system. This little 1/2 ounce brick, we have 2 linear servos, a receiver, and an electronic speed control. This is how we connect to the battery, and this is the motor. Again, a geared brushed motor that should provide plenty of power for up to 3 ounces on this model. This is the antenna to the brick. I call it a brick. This is a typical Z-bend. Let me get it around here. And I want to point out that there is a front and a back to this brick. What will happen is you'll notice on the 2 linear servos, there's a gear to the little electric motor that makes this go back and forth. I'll turn on in a second. This has to go back to control surfaces because if you have a bend, the gear rod, the gear is in the way. So if this is going towards the rear, it will not interfere with the gear. Just keep that in mind as you install it, that the antenna points to the rear of the airplane. This is where the motor plugs in to the brick. And so let's turn it on and see how it works. It is bonded to this DX6 transmitter. It's important that you turn on the transmitter first so it sees the signal. Otherwise, when you plug it in, it goes into the bind mode after about 5 seconds. This is a 1-cell, 150 milliamp LiPo. There is polarity on this. You can't see it clearly, but there's a little extension that comes out here. It's a base, if you will, for the controller. So this is the top. Oftentimes there's a red dot on the bottom. You just have to look, but there should be some little buildup that makes that the bottom. We simply plug this in. So the light's on, it's a steady light, and we're connected. So let's take the transmitter, and if you look here, this is up, down, left, right for the 2 servos. And then for the throttle, I'll hold this and be a little bit careful. Again, all kinds of thrust for a 3-ounce model. So this is just a absolutely magic, wonderful thing. And it works just fine in these smaller Guillows aircraft. What I'd like to do now is just to take a moment to give you my thoughts and demonstrate how we install this ultra-micro ParkZone brick into the Piper Cub. And the key thing is we want to keep it as far forward for center of gravity purposes, and because it's a little bit tricky installation, we absolutely want to put it into the fuselage before we add all the 1/16" square balsa stringers on the outside. It's impossible to get to once that's in place. We'll put everything in, hook it up, make sure everything works, then we add the stringers, cover the fuselage, and you'll be good to go. These are some of the laser cut sheets from the kit. The quality of the wood is very good. Laser cutting is fine. All the parts fit quite well. You can see the spars for the wing, the 1/16" stringers above. This is the wing plan. I've put a little X with a pen on every other rib that I'm going to take out to make the wing a little bit lighter. And this is the initial construction of the wing over the plans. You can see the width that'll be the distance between the 2 wing halves. This is the wing with the 3 1/16" stringers on top have been added. Notice the extra length to connect the 2 wing halves we'll do later on. There's 2 halves connected, straight line on the leading edge, and about 1 3/4 inch on width that matches the width of the fuselage. And if you overlap these and glue them, for these lighter models, it really holds everything in place quite well. There's no indication of dihedral on the plans. I just added 1/2 inch for each wing panel. I think that'll work about right. This is the final wing section with all the overlap and glue. Again, plenty of strength to hold it together. Notice here to save about 1/10 of an ounce, I cut out some of the leading edge. Again, plenty strong for that, but saves just a little bit of weight for the wing. I made a copy on my computer of the tail surfaces because I'm going to cut those out and use them for the 1/16" sheet. Here's the vertical fin and rudder, and notice the stab with the connector to make it just a little bit stronger for the 2 halves. Continuing with the construction, this is the wing struts on the plan. There's 2 of those, the initial beginning of the fuselage with the center keel on there. Standard Guillows construction with the fuselage formers. Notice the T for the top of the former, and make the 1/16" cutouts a little bit bigger for the stringers. That'll help a lot. And again, B1s on both sides. This is a view of those stringers in place with the A3 keel laid in. I sand that a little bit just to help it fit into the slots. And here is a fuselage again. You can see 1/2. Now that that's off, we'll add the other half of the formers, put in the side keel, and there is the beginning of the fuselage ready for the installation of the electronics. This is an important part of the build of any Guillows kit, so let me describe where we are. We've completed the wing that you can see right here, and what I've done is I've made it all in one piece so we can put it on top of the fuselage to make sure that both sides are aligned with incidents, and I'll show you why that's important. So the wing is complete. The tail surfaces are complete. I don't use a built-up method that the kit shows. Are a little bit heavy, they can warp. Much easier to use lightweight 1/16" balsa that works fine with tape hinges. So here's the horizontal stabilizer of the elevator, and this is the rudder fin assembly. What I'll have to do at a later time is cut out a little opening here on the rudder, cut this, but I can do that after the elevator is mounted to the airplane. But the real thing that I want to discuss now, this is very important for your conversion of these smaller Guillows kits or any Guillows kits to radio control flight, is the installation of the electronics. So this is a fuselage to date, and the key thing is when you build the fuselage, if you can look on this diagram right here, you can see that there's a series of 1/16" square balsa that are the stringers that make up the fuselage. We will put those stringers all along here, but we want to install the electronics before we put on the stringers so we have full access to the interior of the airplane. So let me describe that right about now. So this is the ParkZone brick. This is the ESC, servos, receiver, all in one unit. And what will happen is, in the fuselage, I'll make a little shelf and I'll put the brick just like that inside the fuselage. I'll try to keep it as far forward as I can for center of gravity, but that'll fit okay in the fuselage. It's just wide enough. Notice also, as I mentioned before, the front are these gears right here. The back with the antenna goes this way so the control rods can go straight back. So what will happen is tomorrow I'll make a little wood shelf and I will glue this in place. Before I do that, the other thing I want to mention are the control rods. What I do, you can just barely see this, it's very fine music wire. This is 0.025 inch music wire. You want it very lightweight so that it is not heavy. It can fit inside the holes in the ParkZone brick. And the key thing is, we're going to cut a little bit longer length, about this long right here. We're going to connect it to the front of the ParkZone brick so that we can install it before we put on the stringers and just have the control rod exit somewhere back here. There'll be two control rods, one for the rudder, one for the elevator. One will go out one side, one will go out the other side. It doesn't matter which side. Once it's installed, we can see those push rods going back and forth from the rudder and elevator. The other very important trick, and this will save you a lot of heartache, once the brick is glued into place and the long control rod is installed, I'll put on the tail surfaces so I know exactly where the control horns are for the rudder and the elevator. I will trim this music wire an inch or so short. I will make another smaller section of music wire with a Z-bend, just like at the front, to put into the control horn back here. And then what I do is I pretend this is the long rod. I take a little bit of heat shrink tubing. I put the other rod in like this, and I can very accurately adjust it so the elevator and rudders are neutral. When I have it adjusted just right, I'll take a heat gun, shrink the heat shrink tubing, and what you'll have is something like this, a little dab of glue, so it's fixed in place at just the correct distance between the control surfaces to the electronic controls. So this way it can be installed with the rods in place. I can add the 1/16 inch balsa around that so it's built in place. I don't have access to it, but it's the easiest way to get that installed. And remember to keep everything as far forward as possible for center of gravity. Now the other thing that you have to do is think about the placement of the motor. Okay, so this is the ParkZone motor with the gearing right here. It's just a standard motor, good for about a 3-ounce model. And what I do is I take the plastic cowl. This is where the cowl goes on here on the nose. And what I'll do tomorrow is just kind of eyeball where the motor goes. Is just about 1/4 of an inch up from the firewall. I will mark on this how far up and down the mounting bracket is. And then I will build from scrap wood a mounting for the motor, just glue it onto place so it's the correct distance out, height down to put the cowl on over the motor. And that's what I do, so the motor will be all in place. A little bit of right thrust, a little bit of down thrust. The other thing that I've got to do is I've got to figure out where to place the LiPo battery. The battery is always a problem because it's bigger than the airplane. I don't know exactly right now where I'm going to place the battery. What I will do is I will put in the electronics, I'll put in the motor, see how it balances out. I might do a little cutout under the cowl to put that on the front, have it hang out. Sometimes I can make a little shelf on the back. I'll figure that out after everything is in place, the best place for the battery. There's no elegant option with these smaller models with the size of the battery. Now the one other thing I want to point out is the fuselage looks a little bit bare, but when you look at the side view, everything makes sense when you add these side members right here. So this is normally where the wing would connect to each half. Remember what I've done with this, with the complete wing, if you take a rib like this, I'm going to merely cut away this portion so the wing goes flat onto the top of the airplane. And I've done that with my other Guillows conversions. It works quite well. I'll also add just a slight amount of positive incidence so the wing is tilted up a little bit on the front. That seems to help the flight characteristics. And this front part is where the instrument panel goes. Put that here, then all the strings from there. Now the final thing I want to point out at this stage of construction is the landing gear. The Guillows models have a very haphazard approach to the landing gear. I will look at the diagram here, I'll take some music wire, I will bend the landing gear to figure out some way to glue it onto a former. What the directions have literally, these landing gear fairings fold into, go into slots right here. There's no way in the world that's going to hang up. They're for decoration only. I've got to figure out some way with wire to do the landing gear. Again, that is much, much easier to do before you put the 3/16" stringers in place. I've completed the installation of the ParkZone equipment and the motor and the control rods, and landing gear, so let me describe that before we do the covering of the balsa stringers. So here's the fuselage right here. The landing gear is shown here with these wheels, and I'll slide these off. We'll install them later. The landing gear are these, I just epoxied in the music wire. I just bent a kind of shape around there, and that works out well. That'll work out fine. Here is the tray I mentioned for the ParkZone brick, and that is glued in place. And here's a brick, and you can see the Z-bends on each control rod that extend back through the fuselage and go out here, plenty of length. I can overlap and connect them to the rudder and elevator. I put in a little guide here to keep from flexing. I think that's all you need for these short runs. And then I had to carve out a little bit of space back here to make sure they can extend out. So that is complete there. The motor, I made a little shelf of 3 layers of 16" balsa. The motor is taped in place. I'll eventually glue that onto the motor mount at the correct height and distance for the cowl. With these motors, the propeller is screwed onto the drive shaft of the motor. If you screw the propeller on and off a lot, it's going to get loose. I've gotten in the habit of just leaving it screwed on when it's on there. That seems to work better, and that's what we'll do. Notice also that I had to make allowances, cuts, for the black and white motor wires to go through the firewall, through this little hole, then back connecting to the rear of the brick. So that is correct. Remember, there has to be the right polarity to have the prop spin the right way. Just flip it if it's the wrong way. The antenna is cleared here, and then I had to make a little cutout here and here for the motor, the battery connector. So what I'll do right now is install the cowl. This is the cowl. Because I want to keep the propeller on the motor, just to prevent from doing it off and on, I've just split the cowl, and this will fit over the shaft. So we'll do that right now. And that's about what the cowl is going to look like onto the motor. So now that I've done all this, I can start putting in the stringers and the side panels and all that, building up the fuselage because it's done. And what we'll do is just let me take this back off. What we'll do now is test out the motor and the controls. What we do, we turn the radio on first. So the system does not go into the bind mode. This is on. It's on the Piper Cub low throttle. And I will plug it in. We get our steady green light. And if you take a look at the top of the controls here, this is the elevator. Rudder works fine there. Then we'll point the motor away, make sure we can clear the prop, and plenty of power for this smaller model. So that's where we are with the model, and we'll put on the stringers now, and then we'll be ready to cover it after that. Here's a view of the fuselage ready for the 1/16" stringers. The control units and motor are glued in place. These are the side panels for the fuselage where you cut off the top to let the wing lie flat on the fuselage, and you can see that they're cut off both sides in this view. A little bit of down and right thrust for the motor. The control unit is glued into place, and control rods are hooked up. All set for the covering of the stringers. Rudy, thank you for stopping by. We're going to have to do a little video segment now. Is that okay with you? Thank you, Rudy. We have finished pretty much the installation of the ParkZone equipment in the Piper Super Cub. So I've put in the 1/16 inch square stringers. I have access for the motor cable here, connector. I'm still figuring out exactly what to do with that. The nature of this design, the pants are built in, or the strut fairings are built in, so that's there. And you can just see how if you try to do anything to put this in with the 3/16, you're just not going to get there. So everything is connected with the control runs. As you saw before, they go out to the back. What will happen is I will next cover the elevator, put it on. This is what the control horn looks like on the elevator. So you have a horn down here. I'll trim these a little bit shorter in length. There'll be a Z-bend to the control horn on the elevator. This is the extension from the fuselage, and we just overlap that with the heat shrink tubing. Turn on the radio, adjust this to just the right distance, heat shrink it, glue it, and then everything is connected for the rudder and elevator on this plane. Note also the engine mount installation is complete. That fits in with the cowl. This is epoxied in place. Some popsicle sticks on the side just to give it a little bit more strength. And I also, just for your background information, trimmed off the top of the fuselage. So this is the completed wing. It'll go on like this. That's what it will look like eventually. So we're getting pretty close. The next thing will be to sand everything, put on a few more parts, cover it, and then we should be ready to fly. But that is just in a nutshell how we can install the ParkZone equipment with the coverings, and the battery will go in somewhere here. I'll figure that out with the cowl, keep it forward for center of gravity, and that should be a good starting point for your Guillows RC model airplane. We've completed the wood framework. These are the tail surfaces, the wing and the fuselage. They've been sanded, ready to start our covering. I use iron-on covering for these models, a standard iron and heat gun we've all used before. This is the ParkLite covering I use. It's transparent, and it's the lightest weight. I want to show you with this. You can see right through it. It's lightweight and suitable for these types of Guillows models. The wing is completed here. The covering has quite a bit of strength. Just remember not to over shrink it so you don't induce any warps. And this is the fuselage and the tail surfaces. The vertical tail surfaces yet to be covered with the covering. Again, it works. It adds minimal weight for a model of this type. And here's a finished model with the plastic cowl glued on in place and just ready for the finishing touches and to be complete. I've completed my build of the Guillows Piper Super Cub. Here it is. It came out at about 2.5 ounces. You always want these models to be lighter if possible. 2.5 I think I can live with. 3 is the absolute upper limit. I think it came out pretty well. Just some things I'd like to point out is here's the cowl, and I cut it on the bottom to have it fit on the nose properly. I had to add a little bit of nose weight. You can see a bolted there to balance it out. These models always come out just a little bit tail heavy. It's just the way it is. The windshield I think looks pretty nice for these smaller models. This is kind of a prototype just to see if the thing will fly. I cut it out on the outline on the plan. I just use clear Scotch tape to hold it in place, and I think that works pretty well for a smaller model like this. The wheels I had on my own just with the music wire landing gear. I decided to leave this open here for the battery. I put a little bit of Velcro in there. I think for a model this small, you almost don't even need the Velcro, but the battery slides right in there fairly far forward. Wing is glued in place. The struts are glued into place. Here are the tail surfaces, and you can see again the shrink tubing on the 2 wires overlapped with a little bit of epoxy for the movement. So let's go ahead and power it up. Remember, with the ParkZone electronics, and this is what I'm talking about with the ParkZone electronics that is in the nose section here, you have to, if you plug in the ParkZone electronics without the transmitter, it'll go into the bind mode, flashing light in about 5 seconds. So you always want to turn on your radio first, throttle low, make sure that that says Piper Cub on it, which is what it's binded to. It's right there. We'll go ahead and take one of our batteries, and I'll just leave the battery outside for now. Plug that in, and then we can look at the elevator. Down, up, down, then left, right. That should be enough. And then for the motor, I think that'll be enough power. We'll find out when we test fly it. So it balances out okay right at the spar there. So this is the completed model, and we'll see how it flies. Well, we're here in our parking lot. Looks like a very nice day to fly, evening. And we'll go ahead and give a test flight to the Piper Cub. 2.5 ounces. I think everything checks out. We'll just see if we have enough power, and we'll see if it flies. This is the very first test flight. From the get-go, there was a bank problem, and I was a little bit slow, and you can see it going up and down. That indicates that there is the CG is too far aft. So just trying to feel how it goes, and eventually crashed on this first flight. Second flight, I decided to keep my speed up. It started off a little bit better, but still it was squirrely. It was a handful. I do believe the CG is a little bit aft. I don't think there's any warps on the wings. I did check for that. I think the incidence is right. And it's been my experience, this is my 8th Guillows conversion. Sometimes if you have too much rudder control, it can cause flight of this nature. All right, so just finished some of the test flights with this. I think it has enough power. I think I've got a little bit too much rudder, but the plane's squirrely, and as part of the learning process for these smaller models, when they get twitchy and they behave in odd ways, it's tough to fix. So I think what I'm going to do is consider adding a little bit more nose weight. I think it might be a little bit aft center of gravity, and reduce the rudder throw just a little bit. I think there was too much rudder that was kicking it into a spin. So it's a good learning experience about building the plane, and we'll just see if we can tweak it for future flights.